This video will be the second part of 11.3, Module 11, Section 3 from Revealed Geometry on area of sectors. The first video we focused on circles, and now we're going to go to sector. And let's start with what is a sector. And a sector, I always think of it as a slice of pizza, right? Maybe just because I really like pizza. But a sector is a region of a circle bounded by a central arc and its intercepted arc. And so it's a part of a circle, right? And so I have this part. This is called the central angle here. And then the arc, the part of the circle that it captures, is called the intercepted arc. Now, when I say slice of pizza, it can be a little bit misleading because it can be very large. And so up here, this is like a whole pizza with one slice missing. And so, like, if, we're sharing a pizza, and you give me one slice and you take all the rest, this is your sector. You just get, this is just one huge slice for you because you took all the rest, right? And so it could be just one small slice, or it could be something that's greater than, 180 degrees up there. But either way, it's a part of a circle. And so we need to formula. The equation is down there at the bottom. It's a little bit tricky to see, so I'm going to write it here a little bit larger. The area of a sector is equal to, and I don't usually say x, I say it's the m, or the measure, over 360 times pi r squared. And so this is our area formula for the area of a circle, sector of a circle, rather. And if you're looking at this picture below, it'd be the orange part of that circle we're finding the area of. Now that m, that measure, we're talking about the measure, and it could be here. All right, that could be the measure in degrees, because that's the angle, or it could be right here on the arc. The measure can come from either place. It is going to be in degrees, but the measure can be, again, it can be written on the circle. This is maybe 84 degrees of the circle, or it can be written in the angle part. Maybe that's 84 degree central angle. Right? Either way, it's out of the total circle, which is 360, so the measure divided by 360. I suggest, if you're using Desmos or a good calculator, putting that number inside parentheses and then hitting times pi. And I would probably use parentheses again for entering the radius, unless you can square it in your head. Let's look at an example. And so here it says find the area of the sector. So find the area is what we need to do. It does say to round to the nearest tenth. And so area equals m over 360 times pi r squared. Here our measure is 133 degrees. Times pi, and then I would put the radius, which is that 9, in parentheses, and square it. So it's a little times here. If I can get it to be more, there it goes. Right? And then type it all into Desmos. In Desmos, you can type in just like it looks right there, with the parentheses and everything. Parentheses 133 divided by 360, parentheses times pi, parentheses 9, parentheses squared. And you get 94.01. And so we're just going to say here that our area, rounding to the nearest tenth, means rounding to 0, basically. And so our area is about 94 meters squared. Next example, Hector is playing darts. The diameter of the target zone is 18 inches. And the board is divided into 20 congruent sectors. what is the area of one sector to the nearest hundredth? And so make sure you know what you're asking. You're finding the area of a single sector. Right? It also tells you, right from the beginning, it tells you the diameter of the board, of the dartboard, which on a dartboard means we're going from like the edge here to the edge here through the center, all right, not the outer edge, the playable part of the dartboard is 18 inches. And so we cut that in half or get the radius there is just 9 inches. All right. And so two ways to kind of think through this problem. You could do the whole circle. Which would be pi r squared. Pi times 9 squared is 81 pi. And then do the sector. Right? And if the whole thing is 81 pi, and there's 20 equal sectors, we just divide it by 20, and we get 12.72 inches squared. Or if we want to stick to using the formula that we just learned, we would say the area of the sector. And instead of doing m over 360, we want one sector out of 20 equal sectors. So we're doing 1 over 20. We want 1/20th of the whole circle times pi r squared. And you could type it all into decimals just like that. And you would get the same 12.72 inches squared.